Hello everyone, we are back with another question and this is related to trigonometry and geometry. Here they have given you two circles and they have an intersecting region. They are asking you to find the area of this region. So to find this, I will remind you two theorems related to trigonometry. The first one is the sine rule. So let's say you have a triangle here. The angle, this is angle A, B and C, and the opposite sides are simple A, simple B and simple C. So if you have a triangle like this, the sine rule is sine A divided by A equals sine B divided by B equal sine C divided by C. This is the sine rule. The second rule is cosine rule. For the same diagram, for the same triangle, let's say I'm involving, the cosine rule involves all three sides and one angle. Let's say I'm trying to involve angle A. Then the equation will be A square equals B square plus C square. The summation of the squares of the remaining sides minus 2 times BC cos A. We can write the same equation related to the other angles as well. So this is one example. I'll give you another example. So you can write it like this. Let's say if you're writing for B, then it should be B square equals summation of the squares of the remaining sides minus 2AC cos B. Likewise, you can write it for the angle C as well. So keep all these in mind and I will now clear them. Now let's see what data can we acquire from the diagram. So OA and OB are equal because they are the radius. So both of these sides are 5. AP and PB are equal. So both of these sides are 4. And AOB angle is also given. Let's say I complete this triangle here. I will connect A and B. Now you get AOB triangle. If you want to find the length AB, you can either use the sine rule or the cosine rule. Just to practice, I will first use the sine rule. So how to use it? You need to have, I'll write it again. So you need to have two sides and two angles. So obviously you need to find AB. So I'm selecting that side. The opposite angle is 50. Then what is the opposite angle of the radius? From geometry you know that when you have an isosceles triangle, two sides are equal, then the opposite angles will also be equal. Opposite angles will also be equal. So here you can say that these two opposite angles are equal. The summation of the internal angle of a triangle is 180 So when you do a simple calculation, you can easily find that this is 65 degrees. Both of these angles are 65 degrees. Now you can use the sine rule. Sine 65 divided by the opposite side is 5 centimeters equal sine B, that is 50 divided by the opposite side is AB. That is what we are going to find now. Then AB will be equal to sine 50 divided by sine 65 multiplied by 5. So when you simplify this, you get 4.23 as the length AB. Since you found that length, now you can easily find the angle APB. We are trying to find this angle. Since you know 3 lengths, you can easily find the angle using the cosine rule. So now I will use the cosine rule. So the length AB is 4.23 centimeters. Now we are using the cosine rule. So 4.23 square equals 4 square plus 4 square minus 2 into 4 into 4 cos, let's say this is B, cos B. Now let's simplify. When you simplify this part, you get 32. You take it to the other side. Now you have 32 cos P equals 4 square plus 4 square minus 4.23 square. Easily you can use the calculator to simplify this. You get 14.1 here. The other side you get 32 cos P. Then cos P equals 14.1 divided by 32, which will give you 0.441. Now let's take the cos inverse from both sides. Then you get, you can easily use the calculator to do this. So you get 63.8 degrees as the answer. Now we found all the data that we need to simplify this question. Now let's see how to find the region. Now you know that to find the area of a sector, let's say the angle is theta, the radius is r, the equation is pi r squared into theta over 360, the area of a sector. Now let's find the area of AOB. The area of AOB is equal to pi r squared 50 over 360, which gives you 10.9 centimeter square. Let's find the area of AOB triangle. So this is the AOB sector. Now let's find the AOB triangle. The equation to find the area of a triangle is half into base into height. So the base is 4.23. The perpendicular height. Now we need the perpendicular height, which is this height here. So to find that, you need to use Pythagoras. Then that height would be the height would be 4.53. I will not explain this, it's easy. You have to use the Pythagoras. You know the length OA is 5, and you can find this half of AB is 4.23 divided by 2. Then you can easily use Pythagoras to find this height, and it is 4.53. Then the height is 4.53, and the answer would be 0.5 into 4.23 into 4.53, which will be 9.6 centimeters square. Why did I find the AOB sector and AOB triangle? Then only I can easily find, I'll just clear this so that it's more clear. When I find the sector AOB and the triangle, then it gives me, if I deduct, if I subtract 10.9 from 9.6 from 10.9, it gives 1.3. Gives 1.3, and this 1.3 corresponds to this region. Hope that it's clear. This part, 1.3 centimeters squared. Then let's find the other side. I have to use the same theorem. You have to use the same method. So I'll quickly do that. For APB sector, pi r squared into the angle is 63.8 divided by 360. The answer would be 8.91. The triangle APB is half base perpendicular height. Perpendicular height, it's the same way as before. It will give you 3.4. Then when you simplify this, 7.2. Again, now you have to subtract 7.2 from 8.91. Will give you 1.71 centimeters square, and that is this region. Finally, the area, which is the shaded area, will be 1.71 plus 1.3, which will give you approximately 3.01 centimeters square. So it's approximately 3 centimeters square.